Hello everyone and welcome to today's engineering case study. In this session, we will revisit one of the most tragic structural failures in US history, the Hyatt Regency Walkway collapse, and explore what lessons we as engineers can learn from it. In particular, we will discuss why understanding and applying free body diagrams is not just an academic exercise, but a matter of life and death. On July 17, 1981, a horrifying incident unfolded at the Hyatt Regency Hotel in Kansas City. Two suspended walkways collapsed during a dance competition, killing 114 people and injuring over 200. It was a catastrophic failure not just structurally, but ethically and professionally. This tragedy didn't occur because engineers lacked software or tools. It happened because of design oversight, poor communication, and most importantly, a failure to reevaluate the load passes after a change in design. Let's start by looking at the original design. The plan was fairly straightforward. Single steel rods would run from the ceiling and pass through both walkways. That means each rod only supported one walkway, a load the system was well equipped to carry. Had this design been followed, the structure would likely have remained stable. However, during fabrication, the contractor proposed a change to simplify installation. Instead of a single continuous rod, they used two separate rods, one from the ceiling to the first floor and the other one from the first floor to the second floor walkway. On paper, this might have seemed minor, but if you pause and run a quick free body diagram, you will immediately see the issue. This change doubles the load on the first floor connections. Now, those connections were supporting both walkways, not just one. The result? Tragedy. The box beam connections at the first floor weren't designed to handle that increased load. With a large crowd gathered on the walkways, the connections failed and the walkways came crashing down. Again, I want to emphasize this wasn't a materials issue or an act of God. It was a failure to analyze the forces accurately after a design change. This brings us to the core of our lesson, free body diagrams. Free body diagrams are not just for homework or exams. They are tools to visualize, understand, and verify force distributions. A simple free body diagram in this case would have immediately shown the doubled force on the first floor connection. Free body diagrams help us trace load passes, which is crucial in both statics and structural design. Remember, forces don't lie. If we take shortcuts or skip the basics, the consequences can be devastating. So what can we as engineers take from this? Free body diagrams reveal hidden dangers. Don't underestimate them. Small design changes can have big impacts on the force distribution. No matter how advanced our software gets, the foundation of sound engineering remains understanding forces. The Hyatt tragedy is a permanent reminder that engineering decisions affect lives. In our next session, we will explore another modern structural failure, the FIU pedestrian bridge collapse. We will examine how a flawed joint detail and lack of redundancy led to yet another avoidable disaster. Again, free body diagrams and proper structural analysis will be central to our discussion.